Welcome back, everyone. This is seminar 5 for Parametric Scripting and Architecture. And as you can see, what I have on currently is this website called Food for Rhino. This is where a lot of just Rhino and Grasshopper users program or write their own scripts, and this is where they make it available for everyone. It's an open source platform. All you have to do is create your own account for you to download all the plugins available here to help you advance or expand the Grasshopper toolkit. So the one we're going to be downloading is a plugin called Lunchbox for Grasshopper. Let's search for it, and it should come up as the first link. And to download and install this thing is really straightforward. All you have to do is download the latest release, and here it tells you how to install it. Essentially, it's after downloading, double click the download link, follow the prompt, and then relaunch Rhino and Grasshopper, and then you should see it in your tabs list, right? You see, so your tab, if you haven't installed any additional plugins, you won't see this robotics, Lunchbox, Cookup PRC, the ones that I have. But after you install Lunchbox, you'll see Lunchbox and it's all its plugins. Now, unfortunately for this video, we're not going to actually use Lunchbox just yet. I just wanted to go through and show you how to get plugins and install them. Again, they're fairly straightforward. There's nothing really to it. Some plugins will require you to copy and paste the downloaded file and the special folders. So to get to the special folders, so this is just for your future reference, go to File, Special Folders, Components folder. And this is where you can download all extra plugins into the Components folder, and then after you close and relaunch Grasshopper, Rhino and Grasshopper, the plugins should appear in the menu or in the tabs bar. Okay, so what I noticed last time is a major error. So let's talk about this error, and I think we're going to utilize this video to really troubleshoot the error and fix each and every part of the definition. So for right now, what I want to do is focus on the gable section. So I'm going to select everything else and just kind of push it down. And if I go to the gable section and select these two curves that correspond to my gable, you see that the more I increase, so right now the roof structure is set at 5.5 inches. And the floor assembly structure is set at 3.5 inches. And you see how it looks smaller, the depth of structure in the roof, it looks smaller than it is on the floor. And it gets even smaller the more you increase the slope. And that's because we did not actually create a true offset of the original curve inward. We basically just applied the same set of components, or same script, to the interior or the inside face of structure. And that's not going to work out for us because the way these points offset is not an actual true offset. For us to just apply the same script to the inside face of structure, it will work if it's a flat roof, but it won't work for sloped roofs because the slope changes dynamically from its initial point to its final point, and that's not going to be the same distance for all of them. So what we want to do is actually let's right now ungroup this actually, and let's select all of these curves that correspond to the inside face of structure. So I'm even going to ungroup this. So these are the components that correspond to the inside face of structure. I'm just going to simply move them down for right now. Now what I want to do is really just manipulate these curves here. I want to be able to offset these curves. Let me push this out to the side. And then extend their edges far outside their boundaries, and then essentially fillet them. Now I don't think there is a fillet option and then Grasshopper, at least I'm not aware of it. So what we do, we have to kind of intersect the curves and then rebuild them from there is fillet. So we might, I've actually never used this component before, so we might actually experiment with it as we go along. Anyhow, but for right now, we want to basically offset these curves a specific distance. So to get offsets, we go to Curve, Utility, Offset. The offset component requires a curve, a distance, a plane, and the corner condition for the offset. If it's a closed loop curve, you can actually curve the corners or chamfer them and so on. We're not going to worry about that much because we're not offsetting closed loop curves. We're offsetting single line segments. So then the distance for offset is going to be always given to us from our initial parameters. So for right now, I'm going to type in here and I'm going to say this is roof offset. And the distance here is going to be the structural depth. So, and I know I have two curves for my roof, so I'm going to copy and paste this. There it is. So now the curves that I want to plug in are my roof curves, which are these two. So I'm going to plug my first one and then my second. Let's turn off to preview geometry only when selected. And then what I want to do is turn off everything that I don't want to see. So let's see, what are these two curves that are coming up here? There it is. Okay, so we also want to turn on these curves. So you see right now the offset distance is actually going in an undesirable direction. So what we want to do is we want to change the offset plane. So the offset plane is going to be the XZ plane. So I think we can just simply go to vector plane, get an XZ plane, and plug it into the plane. And there it is. Plug the other one into the plane, and there it is. And you see that's also another problem there, is that it's receiving, it's offsetting it in the wrong direction. So maybe what happens if we just reverse this? I'm sorry, not that one. Let's reverse this one. No. So let's type in an expression and do -x commit. There it is. Okay, so we offsetted these in the correct direction, on the correct plane and in the correct direction. Now we would just want to basically work around our curve and offset the two wall edges and the floor. So again, I'm going to go to Curve, Utility, Offset, and I'm going to get this offset and drag it all the way back to my parameters list, and this is going to be my wall offset. So I'm going to plug my wall depth of structure distance into my distance input, and then I'm also going to type in the prefix wall for it. Then I'm going to drag this all the way back here, and then I'm going to copy and paste that one more time because I have two wall edges that I want to offset. And then it's going to be these two lines. This is my first, and then this is my second. And again, I'm offsetting along the same plane, so I'm going to plug my XY plane into this. And you see that this second curve offsetted in the wrong direction, so all we have to do is put in an expression in the distance input, and it's going to be -x. And there it is. So now, same thing, we want to get another offset component and go back to our parameters list and plug the floor assembly structural depth into the distance input, and then go back and plug the last curve that corresponds to the floor edge into the curve input, and then the XZ plane into the plane input of the offset component. And again, we need to reverse the direction of the distance. So under the expression, type in -x, and that should give us a negative value. So you see, for some, if this depth of structure for the wall here was let's just say 2 by 4 or 3.5 inches, these lines would intersect, right? But since the depth of structure is larger than that, these lines do not actually intersect. So to make sure that these lines will always intersect, what we want to do is extend these lines some arbitrary distance that we know whatever value of depth of structure we give it, we will never exceed that value. Now obviously this is at the maximum. This is a 2 by 12 depth of structure, or 11.25 inches. So what we want to do is roughly extend all the curves edges, all the curves endpoints in either direction by about 4 feet. So we're going to go to utility, and then there is this extend curve component. Before actually extend curve component, I want to experiment with this fillet curve component. So it says, yeah, so you see fillet curves as so this is why I've never used this, because I think this requires one closed curve and then it will give you a radius at the at that fillet, and that's not what we want to do. We want to actually, clean the intersection here. So we're gonna have to do it the old-fashioned way, and that's extending the curves, finding their intersections, and then rebuilding the curves based on with new line components. So this is extend. First curve to extend is going to be this one, and then it says type of extension, line, arc, smooth. By default is 0 line. That's what we need. And then it says extension length at start and extension length at end. And what we want to do is go to params, primitive, number, and I'm going to type in a number here and say that's 4 to 8 inches. And I'm just going to rename this to be extension length. I'm going to plug that into each one, and there it is. You see that curve is now intersected. So we probably want to move this somewhere here. And now I want to basically copy that and paste it 5 times. And now I just need to go in order and plug in the appropriate curves into the curve extension component. And you see that we have some problems, like the curve for oh no, I'm sorry, there's no problem. I mistook this, the red axis here of the screen for the offset of the curve. I'm sorry. So yeah, there are no problems. This is great. So let's turn off all these original offset curves. Now what we want to do is intersect these curves so we can get these points, and then reconnect the points to draw new lines. Okay, so let's go to intersect, physical, curve intersection, and again we're going to need 5 of these. So I'm going to intersect this curve with that curve, curve A, curve B, and there it is. That's my point. I'm going to intersect this curve with this curve. There it is. And then I'm going to intersect that curve with the bottom curve. And then I'm going to intersect the bottom curve with the right wall edge curve. And then the right wall edge curve, I'm going to intersect it with my very top curve. Now let's turn off the extended curves. Let's group these tightly here. As always, I like to just maintain a consistent clean definition all throughout, instead of having to go back and tidy up everything at the end. So now I need a curve, go to curve primitive line, and then again we need 5 of these. So I'm going to connect my top point to the start point of 2 of my lines, and then I'm going to, sorry, that's what I need. So now I'm going to use this point to create my first curve, that point to create my second curve. There it is. So now I can use this point as the start point of my third line, and then that point as the end point of my third line. And I can use this endpoint of this curve as the start point of my fourth line, and that endpoint as the endpoint of my fourth line, and so on. And now let's go back and turn off these points, and we have the 5 lines. Now let's double check our work here. When we change, you see how now this is actually 5.5 inches, and if we change the slope, it consistently remains 5.5 inches because it's always offset in 5.5 inches from whatever angle this line is. Okay, so now what we want to do is move these so that we can accommodate the thickness of the wall on this edge condition. So remember, we already figured out that offset distance when we offsetted this curve. So let's turn on preview geometry for selected objects only. You see how this curve actually sits inside. So we basically want to know what plane did we use to discipline this curve, and I believe it was this plane right here. So what we want to do is it's actually this plane, sorry. So we want to use this plane to reorient those 5 curves. So first of all, I'm going to have to join these curves. So let's go to Utility, Join Curves, and then plug the first one, hold down Shift, and plug all the others. And the output, it says Polyline Curve, which means it worked. So now what I want to do is reorient this curve from whatever plane it sits on to a new plane, and we need the orient component. So go to Transform, Euclidean, and there's a orient component. So it says geometry to orient is going to be our curves, source, initial plane, target plane. So the initial plane is going to be an XZ plane about this point right here. So we want to find out which point is that one. Might be this one. There it is. So what I want to do is go to Vector, Plane, XZ plane, and plug a plane into that origin right there, and then use that as your source plane, and then your target plane is going to be this transformed plane that we did way back when, and there it is. So this is the new transformed oriented geometry. So now let's turn off all of these, and now we have these 2 curves. So now what I want to do is basically add the n suffix into this component, so that I'm going to turn off all these, and there it is. And then what I want to do is see where this plugs into my old curve, and it plugs into stream 1 of my pick and choose n component. So I'm going to take this and just simply replace it with stream 1 right there. and then go back and let's delete, well, before we delete anything, so this curve we also utilized for something else here. This is for the dormer profile. So what we want to do is actually plug the new constructed curve right here into the dormer profile right here. And now this is not going to anything, which means all of this is void. So now let's select these two and group them, change that group to a blob outline, and then change the color to red. And then let's name this gable profile curves. And now what I want to do is select everything here and group it. And I'm going to label this group, let me keep everything consistent, dormer. Okay. So this is just going to be gable roof option. There it is. I'm actually going to select everything here and move it out so I can have more room. So there it is. This is the fixed gable option. Now what we want to do is basically repeat all of this construction here for the monopitch. So I believe this is the monopitch. So let's reorganize our definition here. Let's grab these components and put them back where they were, and then let's look at the monopitch component. So the monopitch has two streams. One for the east-west oriented roof, and the other one is for the north-south oriented roof. So we basically want to repeat that same stuff, that same construction for both items. So before we continue on, let's just see what these two components give us. So these two components give us, you see how this is the problem with using just the offset, initial offset to create the roof slope. When the monopitch slope is that steep, this piece, the inside face of structure, actually sits on the outside, which gives us a major error. So this is why we have to go back and then fix this. So let's see where can we apply this change. So first of all, I probably want to just select all these components and drag them down. Just so I can separate them. So this is reading an output of whatever this selector here. So if I say that this is going to be oriented north-south, then these will give me that. Okay, so what I want to do is instead, this curve is okay. There's an error here. That error there is from the fact that this slope is so large that when the roof is oriented north-south, it simply misses that long edge. So I think that error there is actually accurate. When you get that error, that means your roof slope, you set the roof slope to be too large for this structure. So we're gonna actually, let's just change that for demonstration purposes. There we go. So now that error shouldn't be there. Okay, so what do we want to do now is, let's see how to best approach this. What we're going to do is instead of repeating this exactly the same way, we want to build our construction based off of this, right? Based off of this component, and then eventually be able to join them and delete all this. So instead of repeating all of my work, what I want to do is actually just copy all of these components. I might have to reconnect some of them here and there. So copy. I'm going to drag this down here. So obviously instead of 5 for this construction, we're going to only need 4, because we're going to have 4 lines here. So before I continue on, I'm just going to select these four lines and turn them on. And then let's turn on my preview, go back here and turn this off. And now I'm going to simply plug the new lines into these curves now, and let's just see what happens. So I'm going to delete this, and delete that, delete that, and delete that, and let's see what's happening here. So if we go to a right view, we can see that, first of all, our plane is completely incorrect. We want a YZ plane instead of an XZ plane. Go to vector, plane, YZ plane, and we're going to plug that plane right into here. And that should fix the offset orientation. There it is. And now, so the floor here, we want to basically delete this expression, and it'll offset it in the right direction. And then, so here's our original curves, and then there are the curves extended, and then we want to intersect the curves. So we have this curve intersected with that one, and that gave us this point. That point is coming from this curve. Let's turn off these. This curve intersecting with this one. So now we want to intersect that curve with this one, just that. So plug these two like so, and then I want to intersect this curve with my very top curve, my original one, like so. So now let's turn off, not the points. So you can see that there we go. So you can see that these curves are connected appropriately. What I want to do is connect this point with that point. So that point is already connected there. I just need to drag this point and connect it there. And then I want to connect this point with that point. There it is. So I have 1, 2, 3, 4. Now let's turn off these curves and turn on the joint curve. You see it's a joint curve. And now what I want to do is orient this plane correctly. So we want an actually YZ plane instead of an XZ plane for the initial orientation. So this is going to be my source plane plugged into here. And my target plane is not going to be this one right here. My target plane is actually going to come from, let's see if I can find this. There it is. So it's going to come from here. So this is going to be my target plane, and I'm going to plug my target plane right into here, turn on my preview geometry, and there it is. So I can turn off my planes and points. What I want to do is also just turn on this. Uh-oh. There it is. Okay, so everything is offset correctly. Now again, if you go to the right view, you can see that I think there's a problem here. Sorry. So let's actually turn off these and go back to our original offset points, or offset curves. And you can see that I think we connected the wrong curves. We have to connect the appropriate. So let's turn on these curves and turn them off. We have to see which curve corresponds to what. So this curve corresponds to the roof curve, which is right. That curve, which plugs into the second component here, corresponds to the wall, but then the distance for this wall is not the same. So what I want to do is simply delete this one and then copy the one below it, which corresponds to the wall, which connects to the wall distance, and plug that here, and then plug the second curve into this one. And I want to apply a negative x expression into it, and there it is. So that's correct. Now this curve is also correct. This is my second wall curve, and this curve we should just rename for floor offset, and that's correct. The distance is coming from, let's see where it's coming from, structural depth, but what's structural depth? So my floor offset is actually 3.5. I think I plugged in the wrong structural depth into that offset component. So what I want to do is go back, and there we go. And I think I want to do the same thing here because I plugged in the wrong distance. Yeah, because I just simply copied this from here. Oh no, this is correct. Yeah, I initially deleted the wrong one when I copied them over. Okay, sweet. So these are the 4 offsetted curves. There they are, extended correctly. There they are, intersected correctly. And then joined, connected and joined. Okay. So now if I go and change my offset, everything looks great. You see that the distance, the depth of structure in the roof is not changing. Now, the hope here all along is that when I change this to east-west, everything will work accordingly, and it didn't. So we have to go back and see where did this error happen. So these curves somehow did not offset correctly when I changed them to east-west. And see, this is the problem. When you change them to east-west, the direction, well, not only the direction and the plane changes. So what we have to do is actually generate a second set of curves for the east and west. So before we actually construct a second set of curves, what I want to try is a conditional statement and see. I mean, one of the first errors that's happening when you switch the orientation of the roof, this plane remains the same. So what we want to do is basically go to sets and get a pick and choose component, and stream 0 is going to be the XZ plane, and the stream 1 is going to be the YZ plane. So I want to go to a vector plane and get an XZ plane, plug that into stream 0. And now the pattern is going to come from the roof selection. So you see here, east-west is 0, north-south is 1. So I'm going to just take this output of my value list picker and plug it into my pattern here. And now what I have here is the XZ plane. So I can just simply plug that into this plane component, and that should fix things accordingly. But I doubt if it's going to fix the offsets correctly. Let's go to the front view. Let's turn off this. So it is actually fixing the offsets correctly. So that's great. We don't have to construct a whole new set of curves. So let's switch that to east, north, south. Go to the right view, and that seems to be behaving correctly. Now let's see how are they behaving once they're extended. Again, I'm going to go back and switch that to east-west. Go to my perspective. Again, that seems to be behaving correctly. So the last thing that I want to do is this YZ XZ plane. So what I want to do now is get a XZ plane, plug that point into its origin input, get another, or actually I just want to copy this one and paste it. And now I want to plug my YZ plane to stream 1 and XZ plane into stream 0, and then plug the results here into the source input of the orient geometry. So now if I turn off all of my extended curves and turn off my orient geometry component, see, I think I plugged these into the I think these should be reversed. Yep, there it is. So if I switch to a north-south orientation, let's see, where is this problem happening? So XZ is 0 and YZ is 1, XZ is 0 and YZ is 1. So why is it then not? Oh, the source plane. So we also want to do a pick and choose component for the source plane. So we have two source planes. Again, let's go to list, pick and choose. The first source plane is going to be this one. That's for stream 0. The second source plane is going to be that one for stream 1. And then my pick and choose is going to be this value list component output, and then I'm going to plug my resultant output into the source input of my orient component. No? So the thing I forgot to do here, and this is why this wasn't working completely, is plug the results of this pick and choose component to the target input of the orient component. And now we have to also troubleshoot what's happening with this one. So before we decide how to reverse this, let's go and switch this to the north-south orientation and see what happens. So they're both on the outside. What happens if I just simply reverse this? Nope, nothing. let's turn these off and turn on this merged one. This is all correct. So I think I just had them connected incorrectly. So let's just disconnect all of them. And so the source plane is going to be this one, and the target plane is going to be that one. There it is. So now if I switch this to east-west, everything should work appropriately. Okay, great. So what we want to do now is basically take this geometry input and plug it into these joint curves. And let's hide all this. Let's hide all that. And turn on these two. And there they are. So then we can just simply select all of this and delete it. And let's get this closer to all the other components, and also let's get this down here somewhere, and let's move this group out. Select all these, right click inside the group and say add to group, and there it is. Okay, so again, let's go to the front and let's edit our slope and see what happens. And that's great. So now the last thing would be the dormer. Troubleshooting the dormer profile so that we can fix this roof offset. So to get us going here, let's turn off the curves we're working on, and now let's turn on the curves for the dormer and see what are we working on here. So the dormer is fairly easy. What we want to do is essentially rebuild it using these curves. So we know that these two curves are coming from the original dormer component. So all we have to do there really is just copy these two, copy and paste it, get them down here. I'm going to push this down a little bit, push this up. So now I want to make sure that wherever this output of this curve goes, I want this one to go instead of it. So this is really only connecting to this extrusion. So I'm going to connect it here, and then this is also only connecting to an extrusion, so I'm going to connect that one into it instead. So now these have essentially no connection to each other. Now what I want to do is select these two, right click on this red group and say add to group, and then simply delete these two. There it is. That just saves me renaming. So that part of the component is fixed. Let's turn them on. There it goes. So now what do we want to do? The other side of the dormer, this side, is essentially the same construction as the gable, but only utilizes a different slope. So really all we have to do is, let's turn on these 2 points. There they are. Let's turn off all these. So this is what moves the geometry of the dormer back to the back side, so then we can extrude it accordingly. All we have to do is really reconstruct this curves using all this geometry. So what we essentially want to do is select all of these components and delete them. Well, before deleting them, let's just push them down for now. And now what I want to do is get all these components here. Copy, paste. Let's just group them for easy navigation. Let's select all these components, push them down. Okay, so now really what I need to do is plug in all these lines, because these utilize a different slope. It's the same exact gable definition, but it just utilizes a different slope angle or different slope component. So what we want to do is simply plug all these lines into here and apply the changes that way. So I'm going to simply go in order. Since I know I copied everything in order, this should work if I follow all of my outputs and input connections up correctly. Now I'm going to ungroup this one. So now this curve plugs into this move geometry or this mirror geometry. This is my new curve. So what I want to do is, instead of having it come from this curve to mirror, I want it to mirror this one, like so. So now if I turn off these two, and turn off this one, and then let's turn on these four curves, the mirrored and the originals, and they should work. Great. So now let's just delete all of these. Let's select all these components, hover over this group, right click and say add to group. There it is. And the reason I disabled these components is because I don't want the computer to use up a lot of processing power as I'm working around. I want to be able to work very efficiently. So I don't want it to extrude the profile curves every time I make a change. Okay, so now we troubleshooted this small error. Now let's turn off all these curves and let's enable these. And let's also enable all of these. I should have probably saved before enabling all of them. Okay, so there's another small error here somewhere. Let's see if we could find it. Yeah, so something here is not extruding correctly. So this is based off of two extrusions and then a solid union. So let's see, what are the two extrusions here? If we can just go back and remap our. So you see the solid difference didn't really work. I mean, it worked, it didn't give us an error, but it didn't actually work. So we have the two contoured curves, and then we created the boundary out of both of them, and then we're supposed to do, this is supposed to be a solid difference. So let's just flatten these and see what happens. Maybe that will fix it. That's taking a while. So that did it. If you flatten both of these components, that will give us an appropriate solid difference, which would then lead to a correct extrusion. Okay, so this is great. Now let's see if everything here works correctly if we switch out our roof options. So I'm going to go from an east-west orientation to a north-south orientation. Let's actually turn on our geometry preview. and you see there's something wrong here. So this is this nulled out. Let's see. Yeah, so this is oh, that's because we forgot to plug in the new oriented curves into the no. Let's decrease the slope. Oh, so the extrusion is along the Y because we have to create a new pick and choose component, because when we're extruding this orientation of the roof, which is to say when we're selecting option, the north-south option, which corresponds to the value 1, we want to change the unit vector and the magnitude of the unit vector itself. So we want to actually extrude along the Y, and the distance that we want to extrude is also different. So this is why this is kind of shearing the geometry instead of extruding it, because it's actually extruding it along the Y, and we want to extrude it along the X. Okay, so what we want to do is come down here with our pick and choose component and plug the mono option orientation into the pattern input. Go to curve, vector, unit X, plug unit X output into the stream 1 input, get another unit X, and plug its output into the stream 1 input. And now the difference between them is going to be the magnitude of this unit vector, or the extrusion length. So the magnitude or the extrusion length is going to come from some base geometry. So let's go back and see, where did we get these base geometries from? So if we trace back our construction here, that's going to come from a length component that is plugged into a list item component that's receiving geometry from our initial curves. So these are our initial curves. So what we want to do is list out this curve and that curve, get their length, and then plug that length output into the unit vector input. Okay, so let's do sets, list item. Let's do it again, list item. Let's plug the first curve into the list item. Let's plug the output of the segment output of the explode component and the list input of the list item component. And it's by default is index 0, and it's listing the right curve. And now I want to go back to curve analysis, get length, and then do that twice, or copy and paste. My copy and paste keyboard option is not working, so I'm having to do everything manually. So this is my outside face of structure, and this is my inside face of structure. Let's get these here, and I'm going to plug my there it is. Let's get this all back to what I actually want to do is duplicate this, or yeah, let's just duplicate this pick and choose component. Now, so what we want to do is be able to switch back and forth between unit y vectors and unit x vectors. So if the stream changes, then the unit x changes, right? So the stream here, the monopitch is equal to 1. So stream 1 is always going to be for the monopitch here. So we want to make sure this is plugged in, and we want to disconnect stream 0. So we want to connect the unit vector here into stream 0 and this unit vector into stream 0, because this is outside and this is inside face of structure. And then we simply want to connect the results of the pick and choose component into the direction input of the extrude. And that's going to take a little bit because it's having to propagate the changes downstream. And then we want to do the same thing for the inside face of structure. Alright, so that's wrapped up there. Now what I want to do is simply select this unit vector and say remove from group. Select the other one and remove it from the group. And I want to group these appropriately like this. So I'm going to justify them, center them, do the same thing with this. Now I'm going to select all these and say add to group, and there it is. So now that should give me the right changes. There's something wrong there. So let's go back and let's look at the contours and see why is this not contouring the structure correctly. I think the extrusions are incorrect. There it is. So I think we extruded the inside face of structure probably a little bit too much. So again, let's go back and see where we made that mistake. Well, we actually have it here. Alright, so what I want to do to troubleshoot what's going on here, we should temporarily disable all of these components so that our computer won't be bogged down by updating this every time we update something upstream. And now let's turn on these extrude components so we can see them in real time. So we know that these items are being listed correctly. It's just for some reason it's not extruding at the entire length of the curve, or at least the length that's specified. So we have to figure out why is this not extruding it for the entire length. So I think there's something wrong here. So this is the the inside face of structure, and this 78.5. This is 78.5, which is correct. This is 78.5 still. We actually want to plug this right there, and I think that was our error right there. So you see, I think a good rule of thumb, or just a good thing to keep in mind with Grasshopper is because of all of these, because of the visual nature of Grasshopper, sometimes things could easily be overlooked, or just you can just simply forget to connect something correctly, or forget to connect it at all, and that could cause a major error or a major, discrepancy in the model. So now let's turn on. Well, I want to actually turn them on one at a time. I'm going to turn on these extruded geometries. Okay. So now that these are turned on, what I want to do is go back and flip through my options and make sure everything works. If I flip this to east-west, that works correctly. If I flip it from mono to gable, that works correctly. From gable to flat, that works correctly. And then dormer, there's an error. So we have to figure out what is the error of the dormer. Okay, so first of all, let's turn off all of these. We don't want to see them anymore. Or these. Okay, so these get nulled out if it's dormer, which is correct because it's not receiving an input stream 3. This is where the problem is. So let's turn on these curves and see if it's receiving at least the appropriate curves. Let's increase the slope of the gable, but not the dormer, and keep the dormer as such. And now let's also I want to adjust the length of the dormer, and that's right here. What I want to do is actually remove this from this group and take it all the way and put it right here. There it is. So let's make it 8 feet. Okay, so I know it's receiving the right curves. So what I want to do is figure out what is it not receiving here? Why is it not receiving? There's something wrong here, that once the input pattern is 0, 1. So what we want to do is basically reverse these somehow, right? We want the 1 to be true. Right now is giving us 0 as true, 1 as false, but then there's nothing coming into 0 because this is all here nulled out because nothing is selected with that slider. So the input stream 1 is actually the one that's currently active, but then the pattern input is such that the first is positive and the second is negative. So one thing we could do here is, that could be relatively simple, is, let's see, let's go to primitive, we can get a Boolean, and we can plug the Boolean output of the equality component into the Boolean input of the Boolean component, and then we can get an actual value here. And now let's see if we cannot plug these in the right order. Can we not plug false first and then true second, and then plug that into our pattern? But that still didn't work. So I'm going to delete what I just did. Alright, so I think what we want to do is simply, this pattern is going to be accepting index values, and each value is going to correspond to, the index values are inherently built in Grasshopper to correspond to true and false. So true is going to be 0 and false is going to be 1. So if we basically take, true is going to be 1 and false is 0. This is just the way it's listing out the input stream here. So this is not what true and false corresponds to. This is just how the list is being connected here. So what we want to do is take the true equality output from the equality component and just plug it into the pattern here. And that, if you hover over the pattern, you see that it says 1 inherited value from source, and that inherited value is 1 because 1 corresponds to true, and that's the value we inherited. So now I think these are the correct output right there. So one more time, we want to go back and let's turn on our preview geometry. We want to actually enable, let's enable these 4 components and turn off these, and then turn these contour geometries on. Okay, so now what we want to do is go back and switch between our options here. So go to flat, that changed correctly, gable, changed correctly, mono, dormer, go back to mono and change that from east-west to north-south, and there it is. Okay, so everything is working exactly like we want it. Now let's simply enable all the components that we disabled. Before that, I want to actually save. And let's turn off these. So again, there's another problem here. So I think it's because of these boundary surfaces. I corrected this earlier, but I must have I somehow hit Control Z, undo my changes. So what I want to do is, again, make sure you save, and after that, just flatten the output contours here. Flatten. I think that should, no, it didn't fix it. So let's see if this error still happens if we change it to a gable and not a dormer. So this is not extruding in the right direction. So the problem here is that this pattern input came from the east-west, north-south mono pitch orientation. And that's how it switches between unit X and unit Z. But then we know that for the gable option and the flat roof option, they're always going to be going in the X direction. So what we want to do is create another conditional statement saying that you use this cluster of components only if the inputs, the result of these pick and choose components is the one for the mono pitch. And the mono pitch, we know that it's value 2, so this is 0, 1, 2, 3. So we have to kind of create a cluster of components here that says use these only if we're using the mono pitch. Otherwise, use the XY components for everything else. XY unit vectors for everything else. So let's kind of think about how to organize a cluster of components that can give us that. All right, so to create this conditional statement for all the appropriate or the correct unit vectors, we want another pick and choose component. So go to set, list, pick and choose. And I'm going to take this pick and choose component and drag it all the way here so I can plug the roof option value list pattern into my pattern input. And then I want to increase the streams to total of 3. And now I want to plug the correct streams for my correct options. So option 1 is going to be, or 0. The first option is 0 is going to be for my flat roof, right? So that's going to utilize, I actually need 2 of these, so let's copy and paste. And again, we can just right click here and type in out for outside face of structure, and this is going to be in for inside face of structure. So my first unit vector, the longer one that's coming from the out, that's going to be for my 0. So when the pattern 0 is selected, it selects these 2 vectors. Now my second option is the, let me go back here so I can remember. My second option is the gable, so that's also going to be the same thing. It's going to be these 2. My third option is my mono pitch, so the mono pitch is going to come out of these 2 pick and choose components. And my third option is going to be the dormer, but the dormer actually comes out of its own extrusions here with that we've already extruded it separately, so we actually don't need this third input stream. And now I want to connect my output pick and choose component into the input of the direction for the outside face of structure. Let's see. Why is this? So value 1. I'm sorry. You're supposed to plug in Y for the. We're extruding the flat roof along the Y direction. Not the X direction. And we're extruding the gable roof along the Y direction, not the X direction. So I think that should do it. There it is. So we have to also now troubleshoot why is this not subtracting correctly. So the thing I'm trying now is I'm flattening the surface output of the boundary surface components. So let's see if that same problem occurs if I change it to flat. So the problem doesn't occur with flat. What about mono? The problem also doesn't occur if it's mono and dormer. The problem does occur when it's dormer. Okay, so we have to let's try to troubleshoot it for the gable and then try to figure out for the mono. We have to first understand why the error is, or the subtraction component, the solid subtraction component is not working for this roof, or this roof profile. Okay, so one way to troubleshoot this is to actually bake these surfaces to Rhino and then push them out here so we can see what's going on. Now I only want to really work with one of these surfaces. So one thing I could do to just double check that these surfaces can subtract, and the only way for them to subtract is if they perfectly align in the top view or in the XY plane, if they are perfectly one on top of the other, or they align about the Z-axis. So one thing I can do is get my solid tools toolbar here and do a Boolean difference, and it says here select surfaces or polysurfaces to subtract from. So I want to subtract from the solid largest surface, and you see this is a problem. This should be one surface, not two surfaces, right? So I'm going to escape out, and if I hover over and select this larger surface, it says select surface 1 or 2. So there's actually two surfaces there, and only now that there's only two surfaces. So if I undo my deletion there and do a crossing window to select everything, it says 3 surfaces added to selection. I actually only want 2 surfaces. And now let's do a Boolean difference. Uh-oh. So before we actually even do a Boolean difference, we could first correct this problem with surfaces. The number of surfaces on the outside seems to be doubling, right? So if we go back to our grasshopper definition and hover over the number of contours output, it says 34 contours, and on the inside face of structure it says 17. So somewhere along the line something is being doubled. So you see that this line here is dotted. That means there is multiple trees coming out of this, multiple data trees coming out of this pick and choose result output. So if I hover over it, it says 2 locally defined values. If I hover over the results output of the other pick and choose component, it says 1 locally defined value, and it's a closed brep. So somewhere here down the stream, something did not join correctly. You see, I took the 2 breps here and joined them into 1 closed brep. Here is taken in 2 inherited values, not 2 closed breps, and it's given me 2 locally defined values. So what I want to do is right click on this one, right click on the input of the solid union for the outside face of structure, and simply flatten it. And that should fix this dotted line to a straight or continuous solid line, and it should fix it down the stream. So this is now a closed brep, that's a closed brep, and these are 17 defined values. So now if we actually preview the solid differences, so we fixed one problem, but still we have the problem of, so actually let's undo this surface and let's try to do a solid difference here. So I'm going to do a solid Boolean difference, subtract from this one, delete input, yes, select that one, enter. So it deleted the input, but it seems like it just created a union between the two instead of a actual difference. So if I take these two and explode them, it doesn't seem to want to actually delete this difference there. So let's repeat it in a different fashion. Let's do Boolean split. So select surfaces to split. It's this one. Enter. Select polysurfaces that you want to cut with. That one. Enter. So now I have this polysurface, but again, it seemed to want to just split it and keep its whole union. So there's something wrong with the surface geometry that's coming out of Rhino. So one way to double check our work is to just go top view and zoom in all the way to see if those surfaces do not align, but they seem to align. So now let's go back to Rhino and see what is potentially causing this. And it seems to only happen on the gable profile. Okay, so the problem here I think is maybe because of a little bit of redundancy here. So let's try this. I can't figure out why this solid difference is not working for the gable. So let's try, instead of contouring, instead of creating a boundary surface for each set of contours, let's try to create a combined boundary difference. So we already have the first set of curves plugged in here. Let's hold down shift and plug the second set of curves into this boundary outline, and that seems to work. So let's just delete this boundary surface. Let's delete the solid union. Let's turn that on, and before we plug that into our extrusion options, let's see if everything works appropriately this time. So flat, that seems to work. Gable, mono, dormer. Let's go back to the mono pitch and let's change this orientation, north, south, east, west. There it is. All right, so that's great. So the other thing I want to do is contour these surfaces in the reverse direction so I can create the structure orthogonal to all of this, right? So let's first of all see if these work here, and they work. Actually, let's save the creating the structure in the reverse direction for next time when we do the cost estimate analysis, because I think this is, for this seminar, I think we've done quite a bit. So next time we'll be covering the installation. Well, I've already covered the installation of Lunchbox. We'll be covering some of the new components from the Lunchbox toolkit, and then we'll also link Excel to Grasshopper and vice versa. So until next time.